Welcome back to another video. We are still continuing with the graphs of motion. Right now we are dealing with the scenario number 3, which states, I hope you can see that, a bouncy mass. What a bouncy mass means is that we release a certain mass from a certain height, but when it hits the ground it will bounce a few times, like before coming to stop. This is what a bouncy mass means. Let's read the statement here and analyze these graphs below here. A girl throws a ball upwards with a velocity of 10 meters per second from the top of a 30-meter hill. On its way back or on its way down, she fails to catch it, and the ball falls to the ground and bounces 2 times before coming to stop. Okay, this girl here, she threw a ball upwards with a velocity of 10 meters per second, and and then this ball here will reach its this is ball now. Okay, let's continue. This ball here will reach its maximum height somewhere around there. After reaching its maximum height, on its way back, she fails to catch it. You see, it will be back to where it was originally thrown, and then it will hit the ground at this point here. After that, it will bounce to another maximum height and it hits the ground, and after that it will have a second bounce here and then come to stop at this moment here. You see, this is what will happen. And then let's analyze the velocity time graph. Here I only chose one direction, and so that we do not get confused or something like that. I don't want to cause confusion here. But looking at this graph, you can pause the video and think about it. I just want to ask you one question. Which direction did I choose as positive here? Is it downwards positive or upwards positive? You can pause the video, think about it, and unpause the video to find the solution. Did you get the answer? Like, if you see here, you don't even need to think like for so long. You can see here the slope of this line here is positive. Why is it positive? Because it is going upwards. You see, the slope is positive. That means I choose downwards as positive, because if I choose upwards as positive, the slope was gonna be negative and the graph will be the inverse of this. It will look like this. And yeah, let's analyze it. Okay, the girl here throws a ball upwards. When she throws the ball upwards and your positive choice of direction is downwards, that means this ball here will experience a negative velocity. It will eventually come to its maximum height here, where it has 0 velocity, and then it will come back here, like I said, here where it started. It will come back here, but in positive velocity, because your choice of positive direction is downwards and your displacement or your projectile or your ball, it is going downwards. That means it is experiencing a positive velocity. That's why here we have an increasing velocity here until it comes to the ground here at this time here. But upon reaching the ground, it bounced 2 times. This here represents the number of times it bounced before coming to stop. Of course, it bounced here. It stayed in contact with the ground for few seconds, and then it went upwards to reach a maximum velocity at 0. Here, it hit the ground with a certain velocity. This ground here will it will lose some of its velocity, and the ground will push the ball to bounce here. It will give it an initial velocity, if you want to think about it that way, and it will not give it the velocity that it strikes the ground with, but it will, let me say, if this ball here strikes the ground with a velocity of 20 meters per second, and the ground here, it will stay in contact with the ball for a few seconds, and it will give it a velocity less than that it hits the ground with. It can give it maybe 18 meters per second, you see. That's why you see this graph starts here. It doesn't start here. And after that, it will, let's say, no, you choose downwards as positive, and your ball here is going upwards. That's why it is experiencing a negative velocity. Remember that a negative velocity does not mean that the velocity of the ball is small or something like that. What it means is that the velocity of the ball is in another direction, you see. You choose downwards as positive, but the velocity here is going upwards. That's why it is in negative interval here. It will reach its maximum height here, which is here, if you link them, and then it will fall to the ground again, which will experience a positive velocity. When it comes back, it experiences a positive velocity here, and then it will hit the ground again. Let's say this time it hits the ground with a velocity of 17 meters per second. Some of the velocity here will be consumed by the ground here. You see, this ball here will stay in contact with the ground for few seconds before bouncing again, and that's why we start here. If it hits the ground with a velocity of 70 meters per second, it will go upwards with a velocity of maybe 15 meters per second. That's why it starts here, of 15 meters per second. And obviously it will go upwards, experiencing a negative velocity until it reaches its maximum height here, which is there, and then it will fall to the ground here, experiencing a positive velocity, as here suggests, and then it will stop at this time here. Yeah, I hope you can understand that, and let's move on. Now let's look at the position time graph of the motion. Here I choose upwards as positive so that I can have a negative acceleration, and my graph will resemble if you can see here, this graph here and then this motion here, they look more or less the same, you see. I took the ground here as a reference point, but if I took the top of the hill as a reference point, my graph will start somewhere around here, going upwards and so on and so on. This time here is the time it took the ball to reach its maximum height here, and this is the time it takes for it to return to its original position, you see, and then it will start experiencing a negative displacement because your choice of direction is upwards but the displacement is downwards. That's why it experiences a negative displacement here, and then it will hit the ground here. It will stay in contact with the ground before bouncing again, you see. It will bounce and then reach its maximum height here, which is here. After reaching its maximum height, it will return to this position here where it bounced for the first time, and then it will start experiencing negative displacement like so, and then it will also stay on the ground for a few seconds before bouncing again. Like this is the time it takes to be on the ground. You take the time here, you minus the time here, you'll see how long it takes this ball to be on the ground before bouncing again. And this is the time it reached its maximum height. This is the time where it bounced. This is the position where it bounced here, and then it will also start experiencing negative displacement, and that's it. Let's talk about the acceleration time graph here. Of course, I choose upwards as positive. We will have an acceleration here, you see. It will this is the time where the ball hits the ground. The reason we have like this acceleration changing here is because when that ball hits the ground, there's no more gravitational acceleration, you see. Like for a few seconds the gravitational acceleration will not be there, but once it leaves the ground, it will also start acting here. They may look like three separate graphs, but this here represents only one set of motion here. They are not different, you see, because the ground here, the ball comes with a certain velocity. It hits the ground, stay on the ground for a few seconds, and then bounces back, and then so forth and so forth, you see. That's why we have a acceleration time graph like this here. And for now, I want to take two activities to help you answer questions that concern graphs and questions like that. Yeah, let's do the questions and stop the talking here.